Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to go over how to find the inverse of a rational function. So here, we're going to assume that this function is one-to-one. We could check it by graphing the function and notice that it is either increasing everywhere or decreasing everywhere, and as long as that's the case, this function is going to be one-to-one. But here we'll just assume that it's true. The first step is to rewrite it as y equals 2x minus 3 all over 5x plus 4. Switch x and y. X equals 2y minus 3 over 5y plus 4. Now we need to solve for y, and notice that there's a y in the denominator, so we need to get that out of the denominator first. And we can do that by multiplying both the right side and the left side by 5y plus 4. On the right-hand side, those divide out to just leave the 2y minus 3. On the left side, we should go ahead and distribute the x. So we get 5xy plus 4x equals 2y minus 3. Now we need to get all of the terms containing y on one side, so I'm going to subtract 2y over to the left-hand side. We also need to get all the terms that don't contain y to the other side, so I'm going to subtract 4x from both sides. And what we end up with is 5xy minus 2y equals negative 4x minus 3. And you can write that in either order. To finish solving this one, I need to factor out the common y on the left-hand side. So I have y times 5x minus 2 equals negative 4x minus 3. And then I can divide both sides by 5x minus 2 to solve for y. And there's my inverse function. Let me write it with inverse notation. F inverse of x equals negative 4x minus 3 over 5x minus 2. Now, on this line, there was another way that I could have gone. I could have collected all the y terms on the right-hand side and all the terms that don't contain y on the left-hand side. And I'm going to show you that we would have got the same thing. It would have looked a little different for a while, though. So if I did it this alternate way, where I collected the terms with y on the right and the terms without y on the left, I would have had 4x plus 3 equals 2y minus 5xy. Then I could factor out the y. 4x plus 3 equals y times 2 minus 5x. And then I could have divided over the 2 minus 5x. So 4x plus 3 over 2 minus 5x. Is that the same as what we have? Well, it is. If we multiply both the numerator and denominator by negative 1, we'll see it. If we multiply negative 1 times both the numerator and denominator, distribute that through, negative 1 times 4x, negative 1 times 3, there's my negative 4x minus 3. In the denominator, negative 1 times 2, negative 1 times negative 5x, and then we could just rewrite this as 5x minus 2. So we would get the same thing whichever way you went. This would have been an okay inverse function as well. Even though it doesn't exactly look like the one that I found first, they are the same.